Okay, let's start. My name is Michał Wyziński. I'm a senior Go developer at Be Shaping the Future Poland, and I would like to share my thoughts and general background behind the Go language. Worth to say that the language is getting hype right now, especially I think because of the cloud being more popular around and cloud deployments. Also, I would like to say that we at Be Poland also like Golang, and we are looking and training people for Go as well. I will try to make this presentation partially also for non-technical people to see what's Go problems is solving and what actual problems caused the Golang to be developed in the first place. But also I will show some technical stuff, some code. I have also repository public and shared to be viewed as a good starter point for building a web application in Golang. So long story short, I would like to encourage you after the presentation to try it. I think the most important things in Go is that it promotes simplicity and it's well suited for cloud and cloud deployments. So the whole why behind the language, it's well explained in the articles. They are linked below. I will also share the slides so you can read it if you're interested. But the Golang was conceived in 2007, and basically it was designed to solve Google's problems and pain points. It's also worth to mention that the reasoning behind Go is that commonly used languages on the market like C++, Java and Python, but not only, have been built some time ago. They may be somehow unrelated to the environment that we have currently. And the problems that was introduced in the meantime with the multi-core processors, network systems, the massive computation clusters, and especially web programming and network programming were sometimes worked around rather than addressed head-on. Yeah, so the scale has changed, and today server programs contains or compromises tens of millions of lines of codes. There's a lot of developers working on this, and even at Google is a couple thousands of engineers working on the code. So the environment is well fragmented, and it's good to have something that simplifies it and allows to build consistent programming model. And also the build times for the big systems, complex systems can be stretched to many minutes or even hours. It's not very uncommon that some programs or applications are being built a couple of hours. So yeah, so a couple of Google's pain points which caused the Go language to be developed is the most important: slow builds, uncontrolled dependencies, programmers using different subsets of the language, which can be, I think, well noticed in C# or Java when there are like a couple different programming models that can be used. Poor programmer understanding. It's also somehow related to the previous one. Some people are using modern or newly introduced parts of the language. Some people are using just the core parts, which is causing that some developers may find it difficult to understand and maintain the code written by somebody else. Duplication of effort, cost of updates. This is important. Version skills, so hard to maintain of the dependencies of the application. Difficulty of writing automatic tools. So if there's a lot of languages, the languages are complex. It's hard to build automated scripts or tools to maintain that code or to generate another code. Cross-language builds. So basically, Go was designed to address these problems and to solve these problems. And the Go authors, Ken Thompson, Rob Pike, Robert Grismer. So it's worth to notice that no matter how long you're in the software industry or which actually are you using, you are probably using some part of the code or the software that was developed by one of three guys or probably all of three guys together because of C, Unix, Plan 9, distributed operating system. Robert Grismer, which was one of the primary developers at the Hotspot JVM, and the garbage collector was also a developer of the Golang garbage collector. So you would imagine if he has all this experience of building JVM garbage collector, that he could solve some of the problems better and just make it better, writing another garbage collector for another language. So they started with a simple idea that the language has to be readable and simple, and they all have to agree if they put some additional language constructs into the language, not to put more garbage, more additional stuff into the language, which is important because currently modern languages are kind of on a race of putting everything. If they are not typed, they are trying to be typed. If they don't have a functional approach like lambdas or functions, they're trying to introduce that as well. And Go is very hardly defined, and the reason for that is to keep it simple and basically based on minimalism of the language. But it obviously doesn't mean that the language itself it's simple or stupid. Let's say it's more like language is very carefully picked in terms of functionalities and the constructs included. So Go characteristics is C-like syntax, type safety, so it's typed language. It's compiled to native code, so there's no virtual machine. It's garbage collected, so there is actively running garbage collector. Developer don't have to think about freeing the memory. Concurrency is built into the language, and the concurrency, I mean the whole concurrency model, not only concurrency constructs like synchronizing the threads. It's more. I will say more about this later. Standard library, by definition, had to cover basic usages for the modern web and networking development, like JSON serialization, HTTP client and server built into the language, templating. So both HTML templates or the text templates are built into the language, so they don't need any additional libraries to cover that functionality. And it's built and meant to be used also in big crowded places like Google, which I previously mentioned. Like even hundreds or thousands of developers are able to write similar and easy to understand code, and this is because one single programming style. So there is no usually one problem solution developed by a couple of developers will look kind of similar and will be easy to understand by other developers because of the one single programming style. And yeah, it's built to cover current industry use cases like distributed systems, web and network APIs. By definition, it has asynchronous I/O, so it means connections, socket connections to the databases and communicating with the databases. All that stuff from the programming model to the drivers to the databases, all that is designed to be asynchronous. So it's fully async I/O, which allows to improve the performance. It's not blocking the actual threads, so all modern and designed for today. Memory locality, which is related to the garbage collector and improved performance. Readability, which I think I described previously pretty well, why the readability and simplicity is needed. And it's also perfect for low-level interfaces because of the great libraries that natively communicates with the processes, syscalls, and the internals of the operating systems. So cross compilation, this was important part of it, and I have simple example to show that. So there's a lot of different targets that source code can be compiled, and this is binary. Even quite interesting is the fact that you can see there is JavaScript WebAssembly, which is also can be a target system to compile from Golang. But as you can see, there's Linux, there's OS, there's Windows as well for the different architectures, and you can do it everything basically from your development machine. So for example, using a Windows machine, you can build a binary for Linux and just deploy it to the server. It will run under the correct architecture. And as you can see, it's a simple application. This is the application. I have sources and I'd like to share it with you. And as you can see, three different architectures compiled total 5 seconds, which I think is great. That's why it's also very helpful for a developer during the development process. So he can just basically live compile all his changes during the development process. So why readability is important? There's a couple of thoughts shared by the creators of Go. Readability is the defining quality of a good code, which I find true, mostly because code is read over and over. Sometimes it's written only once, maybe sometimes maintained and slightly changed, but usually people are trying to understand, so it has to be easy to understand every time somebody is trying to read and understand what the part of the code is doing. Go itself isn't about the revolution. It's not a part of the race between the languages to be the best, to have most features. It's more about simplicity, and I would say minimalism, which is, I think, the key to simplify things. So it doesn't mean it has like small amount of use cases. I would say the other way around. It's because of the minimalism. It has simple constructs, but they're covering all necessary functionalities. So I think it's good. It's also worth to mention you can add things in order to make something simpler. And yeah, clear is better than clever, especially in software development. I think it's very true. Worth to see that if you are a developer, software developer, usually you are not paid to program or to write beautiful or complex code. Most time you are paid to deliver solutions to the business. And I would say Go fits perfect into this model. Personally, if I would just bet on something and writing my startup, let's say, I would pick Go because of the simplicity and the low risk of just creating an issues, making some mistakes. But yes, sometimes complexity sells better. We have a tendency as a humans to overcomplicate or make things more generic than have to be. So I think Go also as its principles learns us to try define everything in a simple way. It's also worth to mention that usually if we want our code to live long and for example we want to progress in our career or even to be promoted, it's good to have code that can be easily taken over by some other team or some other person. So I think if the code is hard and complex, even if it's the smarter one code, the smarter code, and nobody is benefiting really out of it. So that's the reason simplicity, I think, will sell better also for you as a developer. Worth to mention, a lot of companies betting on Go as well. Since this couple of years, the Go is on the market. Probably all of you know that Docker is written in Go, but also Kubernetes. InfluxDB, I think it's one of the most popular time series databases on the market right now. Prometheus, very common as a part of monitoring environment. Polish company Allegro is writing their very fast caches using Go. CockroachDB, so this is database written in Go that is gaining popularity a lot. It's new SQL, somehow related to the NoSQL, but it's actually an SQL database, but allowing clustering and sharding across the globe. So I think it's greatly connecting towards of databases. A lot of HashiCorp stuff is written also in Go. Console Nomad, the Terraform, very popular on, or provisioning the environments for the deployments like AWS. In terms of popularity across the community, Go is very high in the Stack Overflow survey. I think more than 60% love it. And this is not the full diagram, it's only a part. So I think Go is very high. Also for the JetBrains Developer Ecosystem 2021, Go is one of the top 5 languages developers are planning to adopt. Top 5 languages developers were learning in 2021 is Go as well. Top 5 fastest growing languages, Go as well. So I think it's not only the hype on the market, it's also the hype on the community. The community is very big and growing every day, and is gaining popularity. I think it's growing fast. There is another interesting diagram for the JetBrains Dev Ecosystem 2021. Developers planning to adopt Golang in the next 12 months. As you can see, Go is on the top. So basically, people are willing to transform from a bunch of languages, more than 14% from Python to Go. TypeScript 13%, while the languages in the bottom, as you can see, transforming from Go, the numbers are very low. If people are using Go, usually they are happy with it. Which I think it's also a good sign and a reason to try it. Just 2 success stories to add. If you're interested more, because the articles are great and worth to read, they are linked on the presentation as well. So Netflix Rent is a part of the front-end cache for the Netflix, and they choose to use it in Go because of the lower latency than Java on the garbage collection. And they see it's more productive than C. So it was a perfect sweet spot between C and Java in terms of performance, especially because of the garbage collector. The same as Twitch, they are using in Twitch, they are using Go as a backend system for the chat and instant messaging. And they said, even if you have more than 10,000 Go routines, it's fine. It's very cheap. Probably having that much of operating system pure threads will be hard to maintain and will drain a lot of resources. So, to success story, the garbage collector in Golang itself, it's obviously not as perfect and complicated as the garbage collector in Java, which was developed over, I guess, 20 years or more. But I think its success is because it was built for the specific use cases, and a lot of problems that were in the previous instances of JVM garbage collectors are just no longer applied, because by design the garbage collector is working a little bit different. And I don't want to go that much into details, but mostly because of the escape analysis and memory locality. It doesn't need generational GC with the old generation perm and stuff. It doesn't need compacting that much, because the memory of the Go application, it's not fragmenting that much. It's fully concurrent GC and closely node stop the word happening, because it doesn't need to compact that much. So the pressure itself is reduced on the garbage collector, mostly because simplicity of the model of the Go applications, like the simple structures and pointers without any additional references, it's designed to be performant. Concurrency, as I mentioned in the introductions, so it's not only concurrency primitives used for threads synchronization and blocking. It's more like the full concurrency model built into the language. So the synchronization primitives usually looks like that image over here. In theory, there should be some synchronization and different variables that are shared, used by different threads, but usually it's hard to debug, and sometimes it creates a lot of hard problems to find the spots where the problems actually are with the sharing variables. So Golang is using coroutines, which are very light. Basically, they are not even light processes. They are just language constructs that are acting as a functions that can be run concurrently. They can be executing concurrently with other coroutines. The name that is similar to coroutines, it should sound similar, but the coroutines are even simpler because they are basically functions, but executed by the thread scheduler to run concurrently. They are lightweight and extra cheap. Even thousands of coroutines is fine to allocate. They are multiplexed onto multiple OS threads, so the thread scheduler is taking care of all of that. They hide many of the complexities of thread creation and management, and they allow to write code as like single line by line executed code, but it's actually concurrent. Basically, why it's happening is because of the CSP programming, multi-threaded programming model, which stands for communicating sequential processes. It's basically invented or introduced in the CSP paper by Horst, communicating sequential processes. The whole model is basically very similar to the Unix pipes. So the processes are not sharing the state by sharing the memory or sharing variables. Instead, they are communicating by channels, and they are just sending messages through the channels. So they are basically not sharing anything. They are more communicating by sending messages through the channels. And this is making big difference in terms of designing and implementing concurrent code, but actually it allows us not to introduce the basic problems of synchronization in the first place. So it's blocking semantics by default, but obviously it's concurrent code that looks like linear code, which is, I think, even simpler than the event loops or the looping one-threaded single loops like it's used in Node.js. So I have a very simple example of how it's done. Obviously, it's just part of the example, but actually, as you can see, this function would just run as a single function. But if you put a go before it, it will run concurrently. So what it's doing, it's sleeping 2 seconds and awaiting and sending the result on the channel 1. And the await for the channel 1 is here. And select allows us to pick one of the 2 happening scenarios. So either it will load a message from the channel, or the time after 1 second will send. This is basically creating a channel underneath that will send a message after 1 second. And the select is basically it can be. It looks like it's blocking, but basically it's just awaiting for event to happen. So it's not sleeping, it's not blocking any thread, it's just awaiting for something to happen so the code can proceed. And for this scenario, the first one will sleep 2 seconds. So obviously this channel will send the first message. So the select itself will just print timeout. And this is a similar scenario, but the sleep here is 2 seconds. and the timeout is 3 seconds. So as you can see, this will print result 2, and the whole select will finish after 2 seconds. So it's model that allows to write linear code, but basically there is a lot of concurrency in the meantime, which I think it's simplifying, making things simpler. So there's also a good article link below, but I just picked some of the good quotes from it. So yeah, the simplicity some people may find it too simple, or language being a little bit silly itself, but I think I share the same feeling that the person who said this. It's actually a deep work of genius, sometimes figuring out the problem and how to implement it in a simple way allows us to understand it better, and actually forces us to think it how to really implement it in a simple way instead of just throwing some random functional approach at it. It's good to leave your object-oriented baggage at the door, because the language itself has interfaces and some constructs that may look similar at the first sight, but it's the approach is kind of different. I would say more simple, but it has to be understood correctly to really like it, I think. Fighting it will only lead to frustration, which is what I had at the beginning of learning Golang. Sometimes understanding how to handle errors and stuff, it may be tricky, but if you put some effort to understand it and not fight against it, it will reward, in my opinion. Try to share the same view as the language creators. Rob Pike especially is promoting the language very good on the conferences. There is a lot of good talks on the YouTube that you can see, and try to understand their point of view. I think it will be beneficial, even if you are not sold by the Go approach itself. I think it will be beneficial to watch it and try to understand what was the reasoning behind it. Don't try to force your previous languages approach into Go. Each language has different values, a different world of view, and you can just mix and match based on what you're used to do. And that's true, because if you are experienced software developer, usually you know some good practices how to design applications. You probably applying MVC or hexagonal architecture or DDD into your applications, and obviously this language software engineering constructs can be applied in Go as well. Also, learning the syntax of language itself, it's simple because the language has very limited set of keywords, and the syntax is very easy. So this part is easy as well. I think the hardest may be the transition itself into thinking of the Go way. Yeah, so it may affect your thinking, and I think it's a good sign. So yes, I would like to show you a simple example. I will try to go to my IntelliJ and just load it to you. So basically, I've built a very simple application that, yes, it's running. So what it's doing, yeah, so this is HTML template. So it's fully featured web application rendering some simple Bootstrap application that allows us to list a timeline of a specific user on Twitter. So all that stuff is packed as a simple application, used templating engine. It's using Twitter API and exposing some data. It also allows to expose the same data, for example, Elon Musk, as a JSON. So it has JSON built in. Just can serialize it. You don't need any additional libraries for that. Yeah, so this is a stream of 20 recent tweets by Elon Musk. I will show you the code just briefly, how it's working. And also, I would like to show you the live reloading part here. So the basic, okay, let's start with the code structure. These are my binaries compiled, and this is also one simple executable file. You don't need anything else. And this is the entry point. These are the shared files. Basically, these are packages. This one is for loading configuration. It's only one token necessary for it. And this is the Twitter client, which is defined as an interface with a one single method. And we are creating an instance of it. And this instance is basically created and injected here into the handlers for the specific endpoints. So as you can see, there is no external imports. It's everything from standard library. This one is from the internal, so it's from the project itself. It's parsing the templates. The templates are written in Go HTML. It has great support for IntelliJ, but you can obviously use it from a Visual Studio Code or even Vim. It's very mature. The plugins are very mature. It's very productive. And the IntelliSense works also for the templates here as well. So you can basically see what are the methods, what are the parameters for a specific injected fields into the template. And the handlers itself, for example, the handler that returns the JSON here. So yes, the JSON is just loading the data from the Twitter service and transposing it into the JSON part. So here is the live reload. I'm using some external tool, but basically there's a bunch of them that you can use. So if I put something like print stuff, hey, yeah, it's just basically live reloading. Probably right now a little bit slower because of the presentation, but usually it's second or two just to deploy it, just to rebuild it. So yeah, this is usual developer flow. You can just set up live reload. You can write code here. Obviously, if I make some mistake, it will report some errors that there are some problems with the code. So you can also use debugger and all that stuff built into IntelliJ, but usually you don't need it just for writing simple code. And yeah, every time once it's reloaded, I can just refresh it, and this will refresh the whole application. So I wanted to show you that I have a simple makefile here. It's compiling for the OS X, Darwin, Linux, and for the Windows executable. So this is a simple makefile that is doing all the job. I'm going to just do time make all and having it currently defined as it is. So it's HTTP server templating and the JSON support. It's right now it's 9 seconds. Usually it builds like 5 seconds. So that's the very good and beneficial part of the language. So yeah, there is also GitHub repo, which is open with the code. You can try and play around. The great thing about Go is that this whole application, it's one Windows executable. It's 8 megabytes. So it basically contains a binary. The library is compiled into specific language. And 8 megabytes, if you pack it for the simple Alpine Linux, probably it will be 10 or 15 megabytes in total with fully functional application that is rendering HTML and being proper web application. So yeah, to sum up everything, I think that that's true that some people consider code as an art or compare languages to cars, like language X it's Lamborghini, whilst language Y is something else. even if you don't value that much the simplicity, I think that Go could be considered as a good tractor that just it's simple, it gets the job done. So it's nothing fancy, it's nothing that can be considered as an art, but basically it's getting job done, and it's and it's pleasure that you can just solve business problems without any specific thinking about complex language structures. So a couple of links for you if you're interested will be included in the presentation, and I think that's all what I have for today. I'm ready to try answer some of the questions if they appear. Thank you. Yes, you can write the questions on the chat or raise your hands. Probably whatever works for you. Probably both are possible. Yes, I will leave the tractor and wait a couple of minutes if some questions appear. Yes, why do you think Go is a good choice for cloud development? Okay, maybe I could emphasize this a little bit, especially because of the small images that can be used as a part of the CI/CD, frequent building, fast building. Yes, I think this is the biggest benefit. It's just easy to build a pipeline and build a Docker image and deploy it. It's small, so it's not draining the resources. It's the garbage collector, and the way that the memory management is designed, it's causing that usually it's not taking that much memory. So I think all that sums up to faster deployment and lower bills at the end, which is also important for the business. Yes, I can put link pages again, but I will share the presentation as well. So I think you can just write this one, and I will include the PDF into the GitHub, or I will, if it's possible, I will include it into the LinkedIn conversation or the comment somewhere. Which Go-based web servers would be the best to use? I think the de facto standard is Gin for Golang, and we also have experience using it in a production environment. So this is the top one, and to be honest, I have the most experience with it. If you don't need that much web stuff like business-related stuff, you just want to fully featured HTTP router, you can also go with Gorilla Max, which is more technical, less business, fully featured HTTP router. It's more than a HTTP router. Then Gin is fully featured with a validation, with middleware, authentication middleware, and stuff like that. So Gin, I would say, is more for business usages. Gorilla Max, it's more for technical integration parts or the APIs. Gorilla also have some other plugins. For example, it's implementing fully the WebSocket approach, as it has some sessions, CSRF. So it's more technical, I would say. I'm trying to find the chat. Okay. Cold startup comparing to JVM. I'm not sure if I can do that because I'm not sure if I have JVM. Yeah, well, I think I'm not sure about this, but I think cold startup probably JVM will lose that part. I think it may be comparable when it's when JVM is hot and it's already running. Yeah. Is Go a full stack language? Is more often used in projects with TypeScript or frontend or standalone in pure Go projects? I think Go is basically for deploying backend part of the application, but it can also, if you are doing simple, if you want to have simple HTML with a bootstrap without any single page application, just a couple of HTML pages, it's very good to build in together because it has great integration. The templating itself is built into the language. So executing simple HTML templates, it's very, very convenient to do it all together. So I think if you want to build an application that it's just exposing a couple of simple pages, that's very convenient to do it only using like plain Go and templating. If you want to build more like SPA, you would pick some kind of front-end framework anyway because of the full featured build system around it, like Webpack, React, and all together to probably to correctly compress it and make it fully production ready. So at that point, I would just say to use something else. But for simple proof of concept, basically that's enough, or just for a simple reporting. Yeah, exception handling. Yes, I think I have something. I have something prepared in case somebody will ask for that, because the error handling itself, it's very often one of the first points of the discussion why Go it's not very convenient to use. But I think that the error handling, so maybe just to show you what's the problem about or what the people don't actually like it, and the Golang error handling is because usually the general idea is that if function can just return an error, it's not throwing any exceptions or stuff like that. It's just returning it as a second value returned by a function. So here as a function that it's returning error as well, and you have to check it every time if the error is not nil. And the basic problem itself is not about how to handle it, because I think that's a good idea to treat error as a value, as a regular value that can be returned from a function. I think the more problematic part is that at the beginning, people or developers, yes. So it may be confusing because usually what we want to do is to just by the way, I think I have also this linked in the presentation. So usually the problem is that if something is returning an error, we have a tendency to check if it's okay, then we are doing some nesting. If it's an error, we are doing additional nesting. So the whole idea in Go is just to flip the statements and keep the successful execution of the code aligned to the left. So if it's not an error, we are returning error to the calling function. If it's okay, we are going down as a not intended block of the code, and then we are handling another error. So good organized code and in Go way, it's always successful part aligned to the left, and the error handling is internal. This is not causing a lot of nested parts in the code, which is hard to maintain and debug. This one seems to be clear, and on the first side you can see what was the actual function full process or full workflow. So yeah, we have to think about errors. We can just act as they will not happen. So Google just enforces us to do it. Every time it's shouting at us that, hey, you have to handle that error, you have to handle that error, which may be painful, but actually it's forcing us to handle it. Well, Java forces us as well, but the throwing and catching and exceptions, it's basically the same, because you have also some part of the code that have to catch this exception and somehow act if the error will happen. So it's also nesting the code and adding complexity. So I think it's basically the same. The errors in Go are just values as the other values as well. So and this approach, I think it's kind of interesting as well. Yeah, so even some of the this is good presentation. I'm not sure if it's linked, but yeah, at the point of the presenter was I don't miss exceptions at all, and I have to say I like that approach as well. So yeah, align the happy path to the left, and this will make your life simpler if you are dealing with the errors. How many? Okay, what is GoPro? What's GoPro to unit and integration test, and do we have built-in libraries tools available? Yes, unit testing basically is very good integrated. The basic approach is to use tabular testing. So if we have the, I'm trying to find something good that can be used for that. Okay, we have the function environment or default, so it's loading something from the environment or returning the default one. So yeah, we can just use generate test for the function. This may affect my computer, but yeah, I will add it. It will generate a test stub for you, but basically these are the arguments for the function, variable name or default. So I can very simply just add one test case, fill or fields. So for example, testing if it will return default value or empty and variable. So yes. The arguments will be variable name will be something that don't exist, or default. Yes, I want. And yes, I want this. So I just generated test stub and added one simple unit test for test case for that. Yeah, this will just call the function with the arguments, variable name, and we'll see if this what we got is the actual string that we want. Yeah, so this is a built-in testing part into the language, which is commonly used, and usually you do this for all of the unit testing. It's very common to also set up kind of integration test as well all together with it, because you can just use HTTP util to, for example, to set up a simple HTTP server and just use it from the unit test and see if it's returning correct values. So if you have some simple implementation that it's using database, you can inject a mock of the database, use actual HTTP util to set up the HTTP server, and just do full testing, let's say end-to-end with mocked database. So it's not just simple unit testing, it's a little bit more, and the language encourages you to do that kind of testing. There is also, well, there are also external libraries to do some more complex testing, let's say. We have some experience in production usage of the Golang, which is the Cucumber implementation for Go. Looks like it's very mature and get jobs done as well. 1.5K stars on GitHub. Yeah, the maintenance is very good and works very good. So this is the Cucumber approach, or like fully BDD testing can be applied for the end-to-end testing. So I think, yes, the whole environment around it in terms of testing, looks like it's quite mature, and no problem with that at all. How many concurrent requests does Go REST service support approximately? I never did any kind of testing like that, but usually even the simplest HTTP server, it's not using thread per request approach. It's using goroutine per request approach. So basically, it's not a physical thread tied to a specific HTTP request. It's every request is spawning a coroutine. So even if it's using some kind of database behind or stuff like that, it's not blocking the actual threads. So I would say if you want to measure it, probably it will be kind of related to how much of coroutines you can spawn on the specific machine. With having in mind that probably some of the memory will be also consumed by the metadata of the request itself, obviously. But I don't think it's the amount of the request. In terms of speed, for a simple, I never did how much, but I think because of it's using coroutines, they are very cheap, so probably the performance should be good as well. I will look at some comparisons maybe in the future. I think it's a good point to have that, but I could bet it will behave very good. How it goes with the imitating inheritance. I think you were asking about the duck typing. Yeah, this is the approach with the interfaces in Go. It's not only Go specific, but yeah, it's basically we don't have any in terms of, it's kind of related to the object orientation of the language, but what it says basically, if it walks like a duck or quacks like a duck, it means it's a duck. So it means we don't have to say explicitly specify that some of the structure is extending some kind of interface. Here it's just if we have Twitter client, this is the simple interface. And we have the Twitter client. It's this struct that it's implementing, and the only reason we can use it as a Twitter client itself is because it's just implementing this model. So if I would like right now to implement like a type mock Twitter client struct, I just need to implement. I need to implement so the type it's mock type, and here it's Twitter client. So yes, it's enough to just implement the interface, and now I can use my mock TC as a Twitter client because it satisfies the interface itself. So yeah, I guess that was the question. Hopefully, are there good frameworks, libraries in Go to connect to SQL, NoSQL databases? Yes, the support is good, I would say, especially for the most common ones. The MySQL Postgres driver is very mature. The MongoDB driver itself is delivered by a MongoDB team, so I would say you can have better support. MongoDB driver Golang. It's developed by the Mongo community. They just released a couple days ago a new version that supports Mongo 5.1. So as you can see, the maintenance and the general maintainability of it is very high. Are there any advice to help a new Go for understand find the right Go packages for his project needs? Usually, you would like to not. I think that's it's very common, especially if you're coming from the background when you need a library for everything, like library for HTTP or library for JSON serialization. I would say start small. At least try to leverage everything that standard library gives you. It can really give you a lot of necessary stuff to start with. So you can, I think it's worth to just start looking for external libraries once the standard libraries will not satisfy your needs. Usually it's designed to support you at least in the most common use cases. So the general approach in Go is to start with what you have in the language. There's gRPC. How was your experience? Yes, I never used gRPC, to be honest, in Golang. I used it in my previous projects. So yes, as I would like to have an opportunity, and as soon as possible, I will try to do that. I would say the experience should be smooth because of the fact that gRPC and the Golang itself was basically developed by the same company. So I think they should work very well all together. But I don't want to say that I have some experience with successful deployments. So let's say it's just my guess. Okay, please let me know if I answered your questions or you have some additional ones. I try to do my best, and obviously you can catch me on LinkedIn or send me an email. We can discuss some stuff. I can help you start with. I think it will be good experience, and I really liked it. I switched from Java and Scala and Clojure and all the JVM world to Go, and I'm very happy with it. Doing it for around 2 years, and yes, thanks for sharing your knowledge. I was very happy to share it. I am very happy that you invested your time and give your time to hear this presentation. I'm really keen to help if you need anything or you have additional questions. I'm open to hear it. Yes. Are we good? Okay. So thank you and have a good evening. Try Golang if you have opportunity to do that. Thanks.